software development and architecture experience, and over 20 years of knowledge in identity management and federation. Several technical committees, including SAML, SML, and DSML v2. He was the MC software representative to OASIS, Private Liberty, and Authentication.org. He's serving as a senior solutions architect at Optimal IDAM, who specializes in federation and cloud services. With that, I'll turn it over to Jeff. Welcome, Jeff.
Matt, thanks for the great introduction. As I said, my name is Jeff Bourne. I think I probably worked with some of you in the audience. For those of you who have not met me before, hello. It's about bridging the protocol gap between some of the older, more traditional federation protocols, WS-Federation and SAML2, and we're going to talk about how those interoperate with the newer authentication authorization protocols such as OAuth2 and OpenID Connect. I'll start by talking about different cloud identity management architectures. I'll work out the different federation protocols involved. We'll discuss between authentication and authorization. We'll talk passive versus active authentication. We'll discuss different token types. Into the meat of the protocol transition. And by protocol transition, I essentially mean marrying one protocol to another. We'll talk about how it plays into web services, and we'll talk about social media authentication. And permitting, we'll have a time for Q&A. Now, I do want to stress this is not a vendor pitch. The topics I'm going to discuss are discussed in a platform-neutral fashion. All of these things that I will show you are all things that I've done for our customers and things that we can offer you as a cloud service. Let's look at your typical cloud identity management architecture. We have in the middle, identity management cloud. Left-hand side, we have an enterprise that in this case is going to have one identity providers and more reliant parties. And then on the right side, you see cloud-based identity providers and cloud-based reliant parties. We often refer to these as software as a service providers. Identity providers that you might see in the cloud might be things like Windows Azure, things like Google. Reliant parties might be 365, and other SaaS providers that you might use in the cloud. On the on-premise, an identity provider might be something like ADS, tied to directory, some other enterprise-based on-premise identity provider, and parties could be like on the SharePoint or the other enterprise-based. When we talk about cloud identity management, there's two main flavors I'm going to discuss. One is what we call the hybrid broker, and that there's an identity management platform in the cloud that is a broker between identity providers and reliant parties. And a broker is a identity management platform in the cloud where there's no identities in the cloud. Those could be full with usernames and passwords, or they could be just special information about identities that are top information coming in from an identity provider. This supports external identities, and this is very popular where an enterprise wants to have all their employees stay on-premise in the on-premise name provider, but have a cloud-based identity store we hold information about partners or customers. The entities in the cloud can either be pre-provisioned using a protocol like SCIM or SPML, or even transfer, or just-in-time provisioned, where the cloud identity is created as a side effect of the user signing on with a SAML or WS-Federation-based federation. The flavor that we'll talk about is what we call the pure broker. where the Cloud Identity Management Service that brokers federation messages between identity providers and relying party. There is no identity in the cloud. In your broker model, oftentimes that's needed for data protection or privacy. In some cases, there are legal limitations or just a general need for privacy that gives price the desire not to store identity cloud. And we'll see how both of those models play protocol transition. When a hybrid broker, the inbound claims come into the cloud-based federation service. The names or claims in the inbound claims are used to look the user up in the cloud identities if the user exists, and claims are generated outbound to go to one or more relying parties. In this model, the information in the outbound claims could be partially based on information coming from the inbound claims, and it could be partly based on information that's stored in the cloud. Both those flows of information could combine to outbound claims. It goes without saying that if you have multiple relying parties, the claims to each relying parties could be very different. By contrast, if you look at a pure broker model, you have inbound claims, and then those are transformed into outbound claims. The limitation here is that the inbound claims must be a superset of all the claims going out to all of your relying parties. So you have identity provider coming in, sending claims into the federation service, and you have 5 relying parties where claims are going out to those relying parties. The claim must contain all of the information needed to be transferred to the different outbound claims to the different relying parties. Talk about the different federation and authorization protocols we're going to look at today. First one is SAML2, which is familiar to most everybody on this call. You particularly see that any Java is almost always going to be SAML2 based. This WS-Federation. These have been in common in the industry for a long time. WS-Federation is mostly seen in Microsoft infrastructures. For instance, if you're using Office 365, Azure, SharePoint, or SharePoint on-premise, you're likely using WS-Federation. WS, I often call WS Trust the forgotten protocol because oftentimes enterprises are using WS Trust even though they don't know it. For if you are using Office 365, you're certainly using WS Trust because that's the protocol that forms the basis for the old linked Skype for Business authentication, authentication, and even with Office 2016, active still WS Trust. Now, all three of these, SAML2, WS-Federation, and WS Trust, are essentially federation protocols that are focused around authentication, and the only authorization aspect of it is that they all support the ability for claims to be sent, and claims can be used for doing authentication based on logic that may live on the relying party. But protocols themselves don't speak to any authorization directly. They just describe information about the perm that they authenticated. By contrast, OAuth2 and OpenID Connect are federation protocols, but OAuth2 is often described as an authorization protocol. OAuth2 is considered an authorization protocol. It has built into it the concept of a scope, where it's a set of rights the user is requesting, and those rights are embedded into the federation flow. However, you can authorization without authentication. As a practice, OAuth2 is almost always used in enterprises as an authentication protocol, with some small authorization aspects involved. Connect is essentially a layer layered on top of OAuth2. So OpenID Connect and OAuth2 are very tightly combined. You can do OpenID Connect without OAuth2, although you can do OAuth2 and OpenID Connect. Let's tokens. And WS Trust are designed token agnostic. They're almost always used with SAML1 and SAML2 tokens, but they are designed to convey tokens of any format. They're often used with SAML1 and SAML2 token leads people, if you're in a Microsoft environment, to refer to SAML2 as a protocol to differentiate between WS-Federation and WS Trust using as SAML2 token. Like SAML2, use SAML2 tokens as expected. Types in WS-Federation, WS Trust, and SAML2. Now, OAuth2, there's a few different token types. The access code. The access code is a verified token that is used in the access code grant to give the relying party access to the access token, which is actually the real token that's used to grant access to different services. And tokens, which are long-lived tokens, which are then used to generate access tokens as needed. OAuth2 access token is actually, in implementation, is a sealed token. The format of that token is considered outside the bounds of the specification, and in cases is an encrypted sealed blob of information, and is only meaningful to the identity provider and lighted systems that generated the token. And as I said, OpenID Connect is an identity management layer on top of OAuth2. OpenID Connect has a token called the JSON Web Token. JSON Web Token is obviously based on the JSON format. It consists of claims similar to a SAML2 token, and it also similar to a SAML2 token has a digital signature that used to validate the token's validity. The JSON Web Token is an open standard. One difference between the JSON Web Token and the SAML2 tokens is that it's XML, it's JSON. It is, so therefore it is much more compact. And so it uses the name claims, and the JSON Web Token are much shorter than in a SAML2 token. In general, the JSON Web Token has the advantage of being more compact token than the SAML2 token. The industry, the JSON Web Token is often referred to as a JOT token, given the abbreviation JWT, and they pronounce that JOT. I actually don't know how that came about. I don't get JOT of JWT, but everybody else does, so they refer to it as a JOT token. We got OAuth2 and OpenID Connect, and by the way, if I haven't mentioned it before, when you see OAuth slide, refers to OpenID Connect. There are grants in OAuth2 and OpenID Connect are different flow patterns. Grants defined in the specification, the moment of which is the access code grant. This is of passive and active authentication. The way this works is the user's browser is redirected to the identity provider and requests code. After it authenticates, an access code is returned, and then it's sent to the relying party. The relying party makes a REST call to exchange the access code for an access token. As access code is short-lived, the access token is typically longer-lived. In oddly, that call to get the access code could also return a token, could return a refresh token if so configured. Not well suited for thick clients or Sage web applications because it involves redirects. It's fine on and all supports multi-factor authentication. Now, when I'm talking about multi-factor authentication, I would like to point out that IDAM has recently started offering a multi-factor authentication as a cloud service that is independent of the rest of our cloud federation services. So you can now sign up for multi-factor authentication that you can add to your either premise login pages. It can be added to our cloud login pages, a login page at another identity provider. With that as a service, we support email authentication, authentication, time password authentication, voice message authentication, and support messages to your own. So you provide a variety of multi-factor authentication, and you get that as a service to embed into your on-premise login pages or your pages at another identity provider. Access code grant offers you is it offers you support for the authorization of scope. In a case where the user is presented with a page as part of where he says he's told that the line party is requesting a token with these access, and he can either deny and cancel the process or grant it and the process continues. So we call authorization of scope. So that's code grant. The implicit grant is pretty well the same. The only difference is it's passive only. So there's a passive call where the user authenticates, and after he authenticates, unlike getting an access code back, he will then get back a access token and only a JOT token. Access code grant, this is not well suited for thick clients. It's not well suited for single page web applications. It does support SSO and MFA and supports the user authorization of scope. There's also in OAuth2 and OpenID Connect, the resource owner password grant. This call, it's only clients and single page web applications, but unfortunately does not support single sign-on and does support multi-factor authentication. Now, it can be give the option of supporting single sign-on if the relying party caches UIDs and passwords, caches a token which can then be used to get active as needed. It supports the explicit user authorization of scope because no web page part of the flow. Chance that I'm not really going to have time to get into on this presentation, but I thought I would mention them for completeness. One is hybrid grant. This is OpenID Connect only, similar to the implicit grant. The other one is the SAML2 bearer token grant. That's really a way for the SAML2 Foundation to be bridged to OAuth2 and OpenID Connect. But again, outside the scope of this talk. All right, now we talked about the different federation protocols and token types. Let's talk about a WS-Fed to SAML2 protocol transition. This is more traditional that you might see, and in this case, I showed you the same picture as before. Now I've identified that the enterprise identity provider is WS-Fed. The parties on the enterprise side are WS-Fed and SAML2, and there might be a SAML2 identity provider in the cloud, and they're cloud-based relying parties with either a mixture of SAML2 or WS-Fed. In protocol mapping between WS-Fed and SAML2, there's a couple key things that have to happen. There'd be a mapping between the identities of the tokens that are defined the tokens inbound to the cloud service and out to the relying party. There needs to be a mapping of attributes. This mapping of attributes may or may not involve cloud-based identities, depending on if the hybrid or pure broker model is being used. And single logout is very important in this environment. Forget the single logout aspect of it. Scenario. In this scenario, we're going to use the hybrid broker model, have an on-premise identity provider using WS-Federation, and we have a cloud-based relying party using SAML2. we're going to see the flow. The step, as you see over in the lower right, where the user makes an access to the cloud-based Reliant party. The Reliant party is going to detect that the user has not yet authenticated. This is a session, and he's going to redirect the user to the cloud-based identity management service. The base federation service is going to also realize the user is not authenticated, and he's going to redirect the user to on-premise. So step 2 is a SAML2 authentication request. 3 is a WS-Federation authentication request. Does on-premise authentication, which, as I said earlier, if you want MFA, you can always tie that into our cloud-based MFA service. Located on-premise, he gets redirected back to the cloud-based federation service with a WS-Fed authentication response. At that point, either the user could be looked up if he's in the cloud, or if there's some data involved in federation that might be stored in the cloud. Once done, then a claims is performed, so that based on what Reliant party the user needs to go to, a claims is created that combines information from the inbound identity claims to any information that's available in the cloud identities. A SAML2 authentication response is generated, and the user is redirected with that response to the base Reliant party. And if everything goes correctly, access granted. The user's finished his work and decided he's ready to sign off. So he goes cloud-based identity provider, and he signs off. That's going to SAML2 single logout request to the service in the cloud with a WS-Federation single logout request to the identity provider. He then gets a SFED single logout response sent back to the cloud. And finally, a SAML2 single logout response is sent to cloud-based identity Reliant party. If the user had signed on to 8 other Reliant parties during this process, if he had federated to any other Reliant parties, they'll also get single logout requests on whether or not they were WS Federation or SAML2 protocols. So things that we determined in this scenario is that the premise IDP must provide either an entity to match the user in the cloud, or claims that are a superset of the Reliant party claims that are needed. I didn't mention this when we went through the flow, but if there's a SAML2 relay state that is generated by the Reliant party, then as we go through that flow, that relay state must be preserved so that it is read on the final SAML2 authentication response. The single logout, the multi-protocol single logout, is a critical part of this scenario. Now, what happens when we add in OAuth2 and OpenID Connect into the scenario? So basically, we're going to say it's the same scenario as before, but we're adding Reliant parties for OAuth2 and OpenID Connect. See how that changes things. So scenario 2, we're going to use a hybrid broker model. We're going to use on-premise identity provider using WS Federation, and we're going to have a cloud-based Reliant party using OpenID Connect. In this scenario, we're actually going to use the access code grant flow. So the first is the user to go to the cloud-based Reliant party. The user to request test. The Reliant party is going to realize the user has not yet signed on and is going to generate a OpenID access code request to the Federation service in the cloud. The Federation service is then going to redirect the user to the premise identity provider using WS authentication request. The next authenticate, which may or may involve multi-factor authentication, then gets redirected back to the Federation service with a WS-Federation authentication response. The user be looked up in the cloud if he exists. If not, all of the claims that come in the WS-Federation response and user information in the cloud needs to be combined into combined claims, and that claims are then tied to, is sent back because we're doing the access code response. What is sent back is an access code. So they get redirected back to the reliant, in this case with an access code response, and the client party is going to make the REST call to exchange the access code for an OpenID Connect OpenID Connect token. It could be an access token or a JOT token. In this case, if it's a JOT token, it's going to include all of the claims mapped at the Federation service.
Hey, Jeff.
Yes.
So we're getting a little bit of interference from your line. There's like a fapping sound. I don't know if it's your cord or extension, but it looks like it's interfering, or maybe you even want to dial in on a landline.
Let me try this. Is this better?
So it comes and goes, so we'll give it a try and see what happens.
Okay. I'll also try to talk a little slower. So if you repeat something, Matt, just chime in and let me know if you need me to repeat something.
Oh.
Like we saw in the previous scenarios, the on-premise identity provider must provide an identity to match the user and the cloud identity provider, or that are a superset of the cloud line party claims that are needed. To state for line party must be preserved. The relay state from the SAML2 reliant party in scenario 1. But the key difference I want to point out is that there, as of now, there is no single logout defined OAuth2 or OIC Connect standards. Unfortunately, at this point, single logout plays a part. Now, let's shift gears a little bit and talk about active authentication. When we talk active authentication, we're either talking about WS Trust or OAuth2 or OpenID Connect. If WS Trust, that is a SOAP protocol. The common flavor of active authentication used in WS Trust is the username mixed authentication. Username mixed basically means a user ID and password. OpenID Connect, this is REST-based as opposed to SOAP. The grant talking about is the resource owner password grant. This is authentication only. There's no web page involved. There's no explicit chance for the user to authorize the requested grant, the scope. Multi-factor authentication is not supported in this scenario because a user ID and password is sent. Number 3, which is going to be active authentication. We're going to get a pure broker model and an on-premise identity provider using WS Trust. And we're going to phone application using OpenID Connect and the resource owner password grant. The smartphone app is then, after it does the authentication, it's going to make a REST web service request to a cloud-based reliant party using an OAuth2 access token. So here's the flow. Is that the handheld device is going to collect a username and password. It is going to make a OpenID Connect resource owner password grant request to the base Federation service. In previous examples, I talked about home realm discovery, where had a chance to determine, identity provider he would need to go to, and that was done through a web page. Now, there is no web page that the user sees in this case. Home realm discoveries can still be performed if the username is in the form of domain qualified Windows name or an email address. So now let's assume it's an email address. That is become the most common way people do it. And based on the domain suffix of the email, the Federation service could determine that a specific on-prem identity provider where the authentication should be proxy to. In step 3, a WS Trust authentication request is sent, it's valid, and a SAML1 SAML2 token is returned. The identity management system in the cloud will then map the claims returned back in the SAML1 or SAML2 token, map the claims to a OpenID Connect, either an app token or a OpenID Connect JOT token, and turn those to the application. In this case, we're going to assume that the OAuth2 access token is being used. So the client application is going to make a service call to a cloud reliant party. In that web service call, it's going to use the OAuth2 access token as a authentication header. We're going to take that token out of the header and send it to the Federation service to back user profile information. We're going to basically do just like scenario 3, only it's going to be based on the token rather than a token. So the application collects the username and password, makes call to an OpenID Connect resource owner password grant, makes that to the Federation service. The Federation service does home realm discovery based upon the email suffix and the grant request, makes a WS Trust authentication request to the IDP, gets a SAML1 or SAML2 token, then it's converted to a JOT token, which gets returned to the client application. The client application then makes a REST call to the cloud-based reliant party, passing the JOT token. Now, this token, the JOT token is an open format. It includes claims that can be read by the reliant party, and it also includes a digital signature that the reliant party can validate that token using a public certificate issued by the Federation service. Now, I do want to discuss real quick, since we're talking about handheld devices or phones and other smart devices, I do want to talk about the different OpenID and OAuth2 grants that can be used. Now, if you're talking about the resource owner password grant, that's very well suited for an app on a smart device. If you want to use one of the other grant flows, for instance, the implicit grant or the as code grant, that's certainly possible. The problem is that it's being done from an app on the phone or on the device, then that needs to essentially have a built-in browser that follows redirects. There's lots of apps out there that do that with OAuth2, but it is more difficult. And you do have to be aware that the application then has to basically be able to behave like a miniature browser. The advantage of doing it that way, it does give you the ability to tie in multi-factor authentication and sign on. As before, the application devices can simulate single sign-on, caching credentials, and also do it by using a refresh token. A refresh token is a long-lived token in OAuth2 that allows you to be resubmitted to the Federation service to receive fresh access tokens as you need. Talk about social media logins. Something that we are now offering out of the box for our cloud customers. I have to tell you, if you had told me 5 years ago that enterprises would start offering enterprise applications social media logins to allow their employees or their customers to log in via Facebook, I believed you. But nevertheless, that's where we are today, and enterprises are indeed looking to do this. The reason I want to do it is it's ubiquitous. You know, everybody that uses their services has Facebook, has LinkedIn, has Twitter. These things are ubiquitous. They're everywhere. Everybody has them. Downside is it does require there to be a registration process where the users have to be able to register what social accounts they want to associate with accounts that in the cloud that give them access to different relying parties. Have to ask the question of what should the authentication strength of social media be? In other words, you can Facebook authentication to be where does it fall into the spectrum of authentication strengths that are required to access enterprise services. All the user profile information in some media service is very non-standard. Most do not use OpenID Connect to pay user profile information. You require some proprietary APIs. Also, SLO is either non-existent or non-standard. So for scenario 4, we're going to do social media login using the broker model. We use an on-premise reliant party using WS-Federation. Again, this is a little different from the previous model, and now the reliant party is on-premise, and the identity provider is in the cloud, and the provider in the cloud is going to be social media. See in the lower left, the user tries to access the on-premise reliant party. That realizes that he's not yet authenticated. It's a fresh session, so it redirects him to the Federation service. We use Federation authentication request. Next point, there may be something like a NASCAR set of logos or a way for the user to select what media he wants to log in the first time. The first time through, there's going to have to be a registration process. What he's going to do is on step 3, over on the right, he's going to access code request to his social media identity provider. And then on step 4 to the Federation service, there's an OAuth2 access code response. The next that the service would use a rel to exchange the OAuth code for a access token, and we'll use whatever proprietary mechanisms are needed to get user profile information based on access token. Step 7 is a user lookup, may also be a registration involved, so that in the future it'll happen automatically. Step 8, over on the lower left, a Federation authentication response is generated for the on-prem reliant party. Everything worked correctly, he then gets granted access to the reliant party. That is the end of the slides that I have prepared. So at this point, we're going to open it up for questions. And you should then use the chat to send your questions to Matt.
Yeah, right now questions in the queue, so just go ahead and chat a question if you have anything for Jeff or Jeff. Just a couple minutes here.
So waiting for comments, I do appreciate everybody's time to dialed in to see this presentation. It's certainly a subject that I find very interesting, and I hope you did as well.
While everyone's on the phone, I'll let you know that the presentation was recorded, and I will be sending out an email with a link to the presentation in case you want to watch again or miss something and be able to go back and look at that one more time. I have no questions. If something does come up and you feel like you want to get a hold of Jeff, that's the email on here, but Jeff, do you want to just let everyone know what your email is?
Yeah, go ahead and put this back to the opening slide. too far. There we go. I guess I could have just gone down one. All right, so there's my email address. Everybody's welcome to shoot me an email and ask me further questions. I look forward to hearing from you.
Thanks for your time. We appreciate it.
Let's leave for a few more seconds just in case people are right screen capturing.
Well,
Thank you.
everyone have a great day. Thanks for joining.